Hey guys, Friday the 17th. I'm recording this video today. I apologize I didn't get this posted early enough here. But you guys should have finished your quiz yesterday. You should have already done the review section on page 321. So today we're going to get into lesson 9.5. This lesson is solving using the quadratic formula. Okay, so your note should be titled lesson 9.5, solving using the quadratic formula. That should be the title of your notes for today. I want to take some time. We're going to walk through this lesson here. It's fairly simple, mostly just plugging in values and solving, okay? But we're going to work through this lesson for today. So go ahead and take out your notes. Let me pull up my whiteboard here. Give it a second. Here we go. I don't know if you're familiar with the quadratic formula or not. Hopefully you are. But this quadratic formula is going to be used today. Oops, excuse me. I didn't clear my canvas here. All right. So first of all, in your notes, I want you to put down the quadratic formula. Okay. Oops, what am I doing? Formula. Okay, this formula is, and you should be somewhat familiar with this, hopefully, x equals negative b plus or minus the square root of b squared minus 4 times ac over 2a. So here's our quadratic formula. Okay, we've got x equals negative b plus or minus the square root of b squared minus 4 times a times c divided by 2 times a. So basically all this formula, or all we're going to do here using the quadratic formula, is we're just going to plug in our values for a, b, and c, okay? And then we solve through these for x. So let's take some time and go over the steps here for solving using the quadratic formula, okay? Hold on just a second. Okay, solving using the quadratic formula. Okay, so here's your steps. Okay, for solving using the quadratic formula. I keep putting an R on the end there, not sure why. Okay, so your steps for using the quadratic formula. Number 1, okay, we're going to write the equation in standard form. Okay, so now our standard form this is our standard form here. This is going to be ax squared plus bx plus c equals 0. Now here's the important thing, okay? When we're in standard form here, a must be a positive number. Okay, if it's not a positive number, we're going to need to get rid of that negative before we do anything, okay? So make sure that when we're writing this equation in standard form, this being our standard form, that we have a as a positive number, okay? So that's step number 1. Step number 2 is going to be identify the values of a, b, and c, okay? So in all of these, a will equal a number, okay? Then you'll have b equaling a number, and then you'll have c equaling a number, okay? And again, this has to be a positive number, okay? If it's not, you need to turn it into a positive before you do that, okay? Step number 3 is we're going to substitute the values for A, B, and C into the quadratic formula. Okay, so like I said, we're just going to plug in A, B, and C and basically just solve. And then, so number 4 would be solve. Number 5 is going to be to check. Okay, so here are your steps then for using solving using the quadratic formula. First, we put it in the standard form, x squared plus x plus our whole number with no variable equals 0, making sure that our a is a positive number. Okay, in step number 2, we're just going to identify the values of a, b, and c. Okay, so when I put my formula in this, a is going to be a number, so a would equal that number, b will be a number, b will equal that number, and then c also being a number. Okay, then we're going to take these values and we're basically going to substitute them into the quadratic formula. Okay, just plugging them in. Where B goes, plugging them in where A goes, plugging them in where C goes, and then you solve. Okay, once you solve, then you can check. All right, so these are our steps for using the quadratic formula. Fairly easy, but sometimes time consuming. Okay, so don't freak out if this is taking a while to get done. Just take your time, walk through your steps. Okay, so first we're going to talk about how to identify the values. Okay, so let's say I have an equation 7x squared plus 3x minus 2 equals 0. This is already in standard form, so I don't need to do anything to it. Therefore, I can automatically identify my values as A equaling 7, B equaling 3, and C equaling a negative 2. Okay, so here I can easily identify my values as this being my A, this being my B, and then this being my C. Okay, so we're just simply identifying those values and applying my values to A, B, and C, because these numbers are all in our quadratic formula of x equals negative b plus or minus the square root of b squared minus 4 times ac over 2a. So then I would plug my values into here. So my b would be negative 3 plus or minus the square root of 3 squared, because this is b, minus 4 times a, which is 7, and c, which is a negative 2, over 2 times my a, which is 7. Okay, so I'm just simply plugging in, finding my values for a, b, and c, and then plugging them into my quadratic formula. And then from here, I would solve. Now, let's look at one when our a is a negative number. Okay, remember, we cannot have a negative a. Okay, we need to change that negative a. So there's a real simple way to do this. Okay, let's say I have this. It's already in standard form. All I'm going to do is, because this is negative, I'm just going to flip this sign to a positive. But if I flip this, then they all flip. Okay, and this is basically just the process of dividing by a negative number, which changes all the signs. Okay, but rather than going through the process of dividing all of those, all we have to really do is flip the sign. So my negative 2x squared becomes a positive, my negative 4 becomes a positive, and my positive 9 becomes a negative. Okay, now I've flipped all my signs, okay, so that my a is a positive. Okay, then I find my values. A equals 2, b equals 4, and c equals a negative 9. Okay, then I would just put them into my quadratic formula. So negative b, which is 4, plus or minus the square root of b squared, which is 4 squared, okay, minus 4 times a, which is 2, and c, which is negative 9, okay, over 2 times a, which is 2. Okay, so I would just take these values then and plug them in after I've changed my signs so that my A is a positive. Okay, so we will come across some of these where we'll have to first change our A to a positive number. In that case, really, guys, the end process is just if I change this sign, they all change. Okay, and that's just the process of multiplying by a -1 to obtain a positive is basically the process there. But regardless, so here's how we find our values so that we can plug them into the quadratic equation. Okay, now let's look at some of these. Okay, let's see, I've got 4 over 3. Now here I've got a fraction for my A. Is that okay? Okay, well, we don't really want to deal with a fraction in our equation. So if we end up and I have at the start a fraction for my A, what I'm going to do is I'm basically going to eliminate this 3, and I just saw something that doesn't make sense here. Oh, I think I put the wrong number down here in my notes. Give me just a second. Yeah, okay. So I don't want a 3 with my quadratic equation, with my A. So I'm going to multiply by 3 to make the leading coefficient, which is this, a whole integer, okay? So if I multiply by 3, what happens to that? Well, that then takes that 3 away, okay? I'm looking at something here and it doesn't make sense. 3 times 3, multiply both sides by 3 to make the leading coefficient an integer. That's weird. 3 times 5 is 15. Okay, so let me just pull out my calculator here. Okay, I'm going to pause you for a second. Okay, guys, sorry about that. Just wanted to pause and check on something. I was seeing an error in the math here. So what they do is they multiply by 3, and what they had done in the book is they multiplied 3 times 3, and they called it 12, but it's not 12, it's 9. So it would be 4x squared plus 3 times 3, which is 9x, times 3 times 5, which is 15. Okay, so you're basically multiplying by 3 to get rid of your denominator here, and then you multiply each term by 3. Okay, so once I get it here, then I would put it in standard form, which would be 4x squared plus 9x minus 15 equals 0. And then I could apply my values for A, B, and C. So A would be 4, B would be 9, and C would be negative 15. And then, of course, I would put them into my, into my quadratic equation, or quadratic formula, okay, which is negative B plus or minus the square root of B squared minus 4 times A times C divided by 2A. So then I would plug in my values here into my equation there. So if I end up with a fraction here as my beginning term here, I want to get rid of that fraction. Okay, so I'm going to multiply each term by whatever my denominator is in that fraction. Okay, and the whole idea is to get rid of that denominator. Okay, so if I have a negative number there, I need to divide by a negative to make it a positive. Okay, and I do that to every term. If I have a fraction, then I want to multiply by multiply by the denominator there to get rid of that fraction. Okay, so basically the idea here is that first term, the term that goes with our x, has to be number 1, an integer. Okay, meaning no fractions. Okay, no fractions for our first term. Okay, and then number 2, it needs to be a positive number. Okay, So these are two necessary items before we can place this into our quadratic equation. Okay, so two things that we need to note when we're working through these quadratic equations here. Okay, now let's go ahead and see what we do after we plug in. Let's go ahead and solve through some of these. Okay, so let's say I have 2x squared minus 5x equals negative 2. Okay, first of all, I have an integer for my first number, or my first term, so I don't have to change anything there. It is a positive number, so I don't have to change anything there. Okay, so the first thing I'm going to do is put it in standard form. So I have 2x squared minus 5x plus 2 equals 0. Okay, once I put it in this form, then I can find my values. So a is going to equal 2, b is going to equal negative 5, and then c is going to equal 2. Okay, now I have my values. So what I'm going to do is I'm going to plug it into my quadratic formula. Okay, so I've got negative b plus or minus the square root of b squared minus 4ac divided by 2a. Okay, so now I plug in my values. Okay, I've got minus b, which is negative 5, plus or minus b squared, so negative 5 squared, minus 4 times a, which is 2, and c, which is 2, divided by 2 times a, which is 2. Okay, so I plug in all my numbers here. Okay, so let's take this one term at a time. My negative 5 negative 5 becomes a positive 5, okay? So because I have this negative and this negative, they become a positive. So I have 5 plus or minus, okay, my square root. Negative 5 squared is 25, so this becomes 25, okay? And then I've got 4 times 2, negative 4 times 2, which is negative 8, and then a negative 8 times 2 is a negative 16, okay? So I just multiply this, multiply these two, get 8, negative 8, and then multiply negative 8 times negative 2, which gives me a negative 16, okay? So that's where we get that number, okay? So that's our numerator. Then we have 2 times 2, which is 4. Okay, so now I'm getting more manageable numbers here, okay? So it should be fairly easy from this step, okay? So now let's combine. We've got 5 plus or minus 25 minus 16, which is 9, okay? Divided by 4, all right? Does 9 have a perfect square root? Yes. So we have 5 plus or minus 3, because the square root of 9 is 3, divided by 4. Okay, now from here, I'm going to have two answers because I've got a 5 plus 3 divided by 4 and then 5 minus 3 divided by 4. Okay, so I need to solve for both of these. Okay, so x equals, let's do plus first. So 5 plus 3 is 8, divided by 4 is 2. So x equals 2. That's my first number. Then I go 5 minus 3 divided by 4 equals 2/4, which reduces to 1/2. Okay, so I've got x equals 2 and x equals 1/2. So these are my answers. Okay, now I'm going to check these by plugging them back into my equation. Okay, now we're going to plug these back into the original equation, okay, before we change it into standard form. All right, so let me take this here and erase this. Okay. All right, my computer's freezing up here. Okay, so my answers again are x equals 2. Whoops, sorry. We've got x. Man, my computer's freezing on me here. Okay, x equals 2. Sorry about that, guys. And x equals 1/2. Okay, so we're going to take these and we're going to plug these back into our equation to check them. So we've got 2 times, and we're going to do our positive 2 first. So 2 squared minus 5 times 2 equals negative 2. So negative 2 squared is 4. So 2 times, or negative 2. Positive 2 squared is 4. I mean, negative 2 squared is 4 as well, but negative 5 times 2 is 10. Negative 10 equals negative 2. 2 times 4 is 8. Minus 10 equals negative 2. And 8 minus 10 is a negative 2 and a negative 2. Okay, so we know that this one is correct. Okay, now we plug in our other one. 2. What is my problem today? My 2x squared minus 5x equals negative 2. And I'm plug in 1/2. Okay, so negative 2, or 1/2 squared is 1/4 minus 5 times 1/2, 5 over 2 equals negative 2. Okay, this reduces, 2 goes into 4 2 times, so I have 1/2 minus 5 over 2 equals negative 2, and then subtract 1/2 and over 2, and I get a negative 4 over 2. And that reduces to a negative 2 equals negative 2. So this one is correct as well. Okay, so we're just plugging in values and solving for x, and then we're going to check that by taking those two answers and plugging them back into our equation there. Okay, so fairly easy process. It's a little time consuming, but it's a fairly easy process, so not too difficult to grasp. All right, let's try doing another one of these if my computer would stop freezing up on me here. Okay, let's try another one. I'm sorry, guys. I don't know what is going on with this thing today. I should have restarted it. Not sure why it's giving me so much trouble today. All right. So let's go ahead and start back up at the top. Let's get a new... Yes, I'm aware. What the world? All right, so we've got our new equation of negative 4x squared minus 2x plus 5 equals 0, okay? Now, our first problem here is we have a negative, okay? So we have to get rid of this negative. And basically, the easy process of this is I'm just going to flip all the signs, okay? So I've got a positive, not 5. Okay. So I've got 4x squared plus 2x minus 5 equals 0, okay? So from here, I get my values, okay? A equals 4, B equals 2, C equals negative 5, okay? Then I plug them into my quadratic formula. X equals negative B plus or minus the square root of B squared minus 4 times A times C divided by 2A, okay? So now I plug in my values, okay? So I've got a negative 2, and this is negative because I have a negative here, but my B is positive, so it becomes a negative, okay? Then 2 squared minus 4 times negative 5, and 2 times 4. Okay, so I'm just going to work my way along here. This remains a negative 2. Okay, my 2 squared becomes 4. Right, then 4 times 4 is 16. 4 times 4 is 16. And then 16 times a negative 5 is I believe, a positive 80. Okay, so that's where we get that. Okay, so you're just multiplying all these numbers together. Then this is divided by 8. Okay, now let's combine our like terms. So negative 2 plus or minus 80 plus 4, 84 over 8. Okay, and then we've got 84 does not have a perfect square. So we're going to break this down into, let's see, 4 and 21. Okay, so that one number has a perfect square, one does not. So now I've got negative 2 plus or minus. The square root of 4 is 2, so that comes out. 21 remains in, divided by 8. Okay, now, from here, this step is a little different. I can reduce here, okay? So basically, this can be written like this. Negative 2 divided by 8 plus or minus 21 over 8, okay? So both of these can reduce down, okay? So negative 2 goes into 8. 2 goes into 8, that would be 1/4, negative 1/4, okay? And then 2 goes into 8, 1 and 4. Okay, so now I take this and I basically rewrite this, okay? So now I'm going to move over here. Okay, x equals, all right. Now my negative 2 becomes a negative 1, okay? Plus or minus, okay? That's this. And then my 2 that was out here becomes a 1, okay? And both of these are over 4, okay? Hopefully you grasped that. All right, so basically from this step, we're just reducing negative 2 over 8. Because remember, these are two separate terms here, all right? So you can write them as two separate terms and reduce them down, okay? So my negative 2 goes into 8, reduces down to negative 1 and negative 1/4, plus or minus, and then my 2 reduces down. So I've got 1/4 and 21. Okay, so here's where I'm at right now. Now, when I have a 1 outside of my radical sign, I technically don't need to write that 1 there. Okay, so basically I could write this as negative 1 plus or minus the square root of 21 over 4. Okay, so this here is my answer. All right. Let me just check my notes here. Yeah. So this is where it starts to get a little confusing. All right. So this would be my answer here. I still have two answers because I've got a plus and a minus that I have to solve for. Okay. So let me write this off to the side here so we don't forget what our answer is. Okay, so that's our answer. Let me clear this stuff off and we're going to check. I'm going to show you how this works here. The check can get a little confusing just because you've got all that, those square roots and stuff like that. But okay. So we go back to our equation. Okay, so we've got 4x squared plus 2x minus 5 equals 0. Okay, and we're plugging this in for all of my x's. Okay, so I've got 4 times negative 1, let's do plus first, the square root of 21 over 4 squared plus 2 times negative 1 plus the square root of 21 over 4 minus 5 equals 0. Okay, now what we're going to do here is we're basically going to factor this out here because this is negative 1 plus the square root of 21 divided by 4 times negative 1 plus the square root of 21 divided by 4, okay? So we're basically, what we're doing is we're saying negative 1 plus the square root of 21 divided by 4 times negative 1 plus the square root of 21 divided by 4. And we're going to factor this, okay? So my denominator factors really easily. 4 times 4 is 16, okay? So my denominator will be 16, all right? But here's where this gets tricky. I've got negative 1 times a negative 1. That's a positive 1, okay? Then I've got a negative 1 times a positive square root of 21. So I've got a negative 1 and the square root of 21, okay? So we're foiling this, all right, just like we normally would, all right? Our first term times our first term times our last term, and then our last term times our first term. So negative 1 times a positive square root of 21 is a negative 1 and the square root of 21. And then square root of 21 times the square root of 21, that removes the radical sign and makes it 21. Okay, so whenever you multiply a radical by the same radical, remember it just drops the radical sign. Okay, so we factor this out here. Yeah, we factor this out here, and this is what we get here. So we're going to combine our like terms. We've got a negative and a negative. So now I've got 1 minus 2 and the square root of 21 plus 21 divided by 16. Okay. I just noticed I did that wrong, huh? Okay. On my notes, I had it wrong, but so here then is my is the result that goes up here. So now I have 4 times 1 minus 2 in the square root of 21 plus 21 over 16. Okay. Okay, so this is the squared version of this. Okay, hopefully you grasp that. We're just taking our first term times our first times our last times our first, and our last times our last. Okay, and just multiplying those out, and that's where you get that from. Okay, then here, okay, I don't have to square anything, but my 2 and my 4 can reduce out. Okay, so now I have negative 1 plus the square root of 21 over 2, because 2 goes into 4 2 times, minus 5 equals 0. Okay, so hopefully you're hanging on here. I know this is a lot of information, and I'm trying not to go too fast here. I'm trying to explain everything clearly. Really, it's just the checking that gets complicated. The process itself is not too difficult, but once you start getting radicals that you're squaring, it kind of gets confusing. But okay, here we can, first of all, 4 goes into 16 4 times, or no, 2 times, 4 times. So, and then I can combine this and this, so I've got a positive 22 minus 2 and the square root of 21 over 4 plus a negative 1 plus the square root of 21 over 2 minus 5 equals 0. Okay, now typically we would just add these together, but what's the problem with adding a fraction with a denominator of 4 and a denominator of 2? You can only add fractions with the same denominator. So I have to make this denominator a 2. How do I do that? I multiply it by 2, okay? Which means then that I'm multiplying all these terms by 2 as well. So I have, this stays the same, 22 minus 2 in the square root of 21 over 4. Okay, my denominator becomes 4 because I'm multiplying 2 times 2. okay, which gives me 4. 2 times 1 is a negative 2, and 2 times the square root of 21 is 2 and the square root of 21. Minus 5 equals 0, okay? So we have to still make sure that our denominators equal or are the same number before we can add these together, okay? So I've got, let's add our whole numbers. We've got 22 and a negative 2, okay? That gives me 20. So I've got 20. And then I've got a positive 2 and 22 in the square root of 21 and a negative 2 in the square root of 21. So those cancel out, giving me 4 minus 5. 4 goes into 25 times. Minus 5 equals 0. So 0 equals, this ends up being 0, equals 0. Okay, so the check process can be kind of confusing and long, okay, but we just need to take it one step at a time, follow all the rules that we know about doing multiplying and things like that, and take it one term at a time as you're going through the checking, okay? So I know that process can be long and confusing. Just slow it down, write neatly, follow one step at a time, and work your way through there. Okay, so that's how the check works on those more difficult ones. All right, let me do another problem just so that we get a good grasp on how to use this quadratic formula. Man, my pen is just not working today. For some reason. Come on. Sorry, guys. Give me just a second here. Okay. For some reason, my canvas just doesn't want to clear today, so I'm really having trouble with this thing. I should have restarted it before I started videoing, but let me try reopening it. Hopefully it'll work here. Okay, or not. So maybe we'll have to just stop where we're at right now. So we're on practice problems 9.5. What I'd like you to do is in the first section here, in the first section of your practice problems 9.5, it says write the equation in standard form and identify the values. So that's pretty simple. Just put in standard form and write what your A, B, and C equals. Okay, so you can do the blue tabs, 1, 2, 5, 9, and 12 for those. And then on solving each equation using the quadratic formula, I want you to do numbers 13, 14, 17, and 18, okay? So we're looking just at page 224 for your homework for today. Just 13, 14, 17, and 18, and then the blue tabs on the first section there, 1, 2, 5, 9, and 12, okay? So your homework for tonight is basically just the blue tabs 1 through 18 on page number 324, okay? If you have any problems, any issues, give me a call and I'll work through them with you since my computer is just not cooperating right now. So we'll work through them if we have any issues. The process of this is fairly simple. We put it in standard form. We identify our A, B, and C. We plug our A, B, and C into our quadratic formula, and then you just solve it one term at a time. Okay, go through solve it one term at a time until you get to the bottom there and solve for X. Okay, so give it a shot. Let me know if you have any issues. We'll do a review if we need to do a review. But that's your work for today. So just numbers 1 through 18 blue tabs on page 324 for your homework. All right, guys, hopefully that was not too confusing to you. As I said, call me if you have any issues, and we'll work through that. All right, guys, have a good day. Again, this is for Friday, the 17th, so make sure you get your homework submitted by the end of the day. All right, That's all I have. Talk to you later.